Now we are going to solve a problem which is lowest common ancestor. So in the LeetCode, the problem number is 236. So it is a problem on binary tree. So if you want to understand what is meant by LCA or lowest common ancestor, more you can click on this button and you can read this on Wikipedia. Now let us understand actually what is meant by LCA, lowest common ancestor. You need to understand what is meant by LCA. So first of all, you need to understand what is meant by LCA. Here LCA is nothing but lowest common ancestor. Let's say this is the given tree that you have it, and they're asking to find these values. So that they're asking the LCA of 4, 7. Here you can see 4 is here, 7 is here. Okay, and they're also asking LCA of 5, 9, and 5 is here, 9 is here, and 2, 6, where 2 is here, and finally 6 is here. So let us find what are the actual values one by one, so that you can get more clarity what is LCA. So the name itself suggests that lowest common ancestor. Okay, let us find these three values. First one is 4, 7. Okay, so the 4 you can see here and 7 you can see here. Okay, the lowest common ancestor, the ancestors of 4 is what? Up to the root. So this is the root. So here this is the root, here this is the root. So the ancestors of 4 is we have 4, 0, 1. So the ancestors of 7 is we have 5, 0, 1. What is the common in that? What is the common in that? And what is the lowest one, which is 0? So here the value is, okay, if sorry, that is 2, sorry, that is 2, not 0, which is, if that is 0 also, if that is 0 also, no problem. So 5, 9. Now in this you can see 5 over here, 9 over here. So the ancestors of 5 you can write down here. So which is 5 itself, it itself can be, it also be an ancestor. So 5, 2, 1, that's it, up to the root I said. So now the ancestors of 9 that we need to write. So 9 itself, 3, 1. Now you can see 1 is the ancestor that you can get over here. So this is the LCA of 5, 9, and this is the LCA of 4, 7, and this is the LCA of 2, 6, where 2 is here, 6 is here. Now if I write for, also you can see here. If you want no confusions, you can also see here. Okay, so 2 is here and 6 is here. 2 is here and 6 is here. If you write for 2, which is 2, 1. If you write for 6, which is 6, 5, 2 and 1. You can see 2 here. 2 is the lowest common ancestor, that becomes our answer. So that way, if anyone gives you this root, and if anyone gives you 2 nodes, so basically if you want to know the problem statement clearly, what they will give and all, so basically they will give you the root. First thing, they will give you some p and q. So these are the 3 parameters that they will be going to give you. So after that, first the simple thing that always you will check that if root is null or not. If root is null, here itself you will simply return this. You will simply return root, because you have nothing, so you are simply returning this. So after that, so you are going to traverse to the right side. Means first you need to traverse to the left side, then you can go to the right side. Let's say this is some f function and this is f, and you can recursively call the root left. You can go to the left side and again you can call this pq. Okay, again you can go recursively, and you can, let's say this is right and this is, you can say root left, sorry, this is root right, because the root left has been already computed. So pq, done. So we have calculated the left, right, and the final check is if left and right, because both the conditions, left and right, both the conditions are true, then you can simply return. So these are the simple cases, these are the full code. And at last, so this is the at last condition, you can simply you can check, this is with the help of ternary operator. So if left is there, you can simply take left. If that is not there, you can simply take right. So this is as simple as that you can see code over here. Now the main thing that we need to understand is what is the time and space complexity for this. As you can see, as we are going that through the recursion, so the time complexity would be order of n, and the space complexity would also be order of h. In the worst case complexity, h means here height of the recursion tree. Okay, in the worst case the space complexity can go also up to order of n, which is the given number of nodes if that is a skewed tree. So now this is the 236. I will be going to code this and I will be going to show you how this looks like. So the first check that we are going to do is if root is equals to null. If root itself null, you can simply return as null. After this check, then you need to check again that if root is equals to p, or means sorry, I forgot to mention this condition in the pseudo code. Now you can check that if root is equals to p and root is equals to q, okay, any of these conditions satisfy, then also you can return true. So let us understand this also. As I already said, so you can see this is, you are getting 2 here. So as you can see, the node itself can also be a simple LCA. The node itself is a LCA here. The node itself is a LCO here, because the node is 2 and the value is 2. Okay, and if you see here, the node itself can also be a value. So that's the reason that we are counting that. In the code, if you see, if the root is equals to p or q is equals to q, then we can return simply true. So not true, we need to return true root. Why we are returning root? Because the root, ultimately we are going up to traversing up to root. So finally we are pq root means we are going to return root, because we are going to root. Now the main condition is tree node, and we are let's say I will be going to say left. In the left, I will be going to recursively call this lowest common ancestor function. You can make another function inside that also you can call, but I am simply I will call here only. So root left comma p comma q I am passing here. So similarly you can duplicate this, and you can say as right. So inside this you can simply pass right. Okay, this is as simple as that. And finally, if you got the left and right, if you got this left and right as true, then what you can do, you can simply return as, okay, ultimately we are going to root, so that's why we are returning that. If you are not going up to the root, what you will go into return? You are going to return. So basically, if you are going up to the root, so these are the conditions if you are going up to the root. If you are not going up to the root, if you are just having the left, okay, if you are just having the left, then you can simply return the left, or if you are not having the left, you can simply return the right. So this is a simple ternary operator. Now if you run this, you can see this will be running absolutely fine, and if I submit this, it will be going to submit, and you can see all the test cases will be passed. So you can see all the 33 test cases has been passed. So if you like this video, please do like, share and subscribe for this video. Thanks for watching up to now.